Hey everyone, today we're focused on Chapter 2, Section 5, Dividing Polynomials. We're going to go over those examples that we talked about in class yesterday, as well as looking at some different strategies, including synthetic division. So we're going to do traditional long division with polynomials, as well as synthetic division today. As I mentioned in class, the notes sheet that you have includes a section for you to write down the steps. What I would stick with is just making sure that you remember the DMS cycle and also including the B for bring down. So don't forget we're dividing, multiplying, subtracting, and then bringing down the remaining term until we've brought down the last term and completed the cycle. So you want to make sure that you complete that cycle after we do the last term as well. So I'm going to walk you through those two examples that we had in class yesterday, just so that you can see the notes completely, and if you had any questions, hopefully I will answer them throughout this process. So we're doing the function 3x to the fourth minus 5x to the third plus 4x minus 6 divided by x squared minus 3x plus 5. Now we did talk about yesterday the fact that you do need to include any missing terms. So in this case we do not have an x squared, so I'm going to insert a 0x squared into my dividend so that I have that as a placeholder moving forward. Okay. When we work with long division of polynomials, we're really focused on the first term of the divisor and the first term of the dividend as we proceed through each step. So I like to chunk my work out into 3 steps, which is my DMS cycle. So the first thing I'm going to do is my D for divide, 3x to the fourth divided by x squared, and that is going to be equal to 3x squared. So that quotient goes on the top of my division problem as one component of the solution. That's the first term of my solution. It also fits in to the multiplication step. 3x squared then gets multiplied by my dividend. So x squared minus 3x plus 5. And when I multiply that out, that turns into what I'm going to subtract. So 3x to the fourth minus 9x to the third plus 15x squared. So there's one complete DMS cycle. So I'm going to plug that in to my work. Complete that subtraction step. So 3x to the fourth minus 3x to the fourth gets canceled out. Minus 5x to the third minus a negative is a plus. Plus 9x to the third gives me 4x to the third. And minus 15x squared. Don't forget your b. You want to bring down the next term, which is plus 4x, and then repeat. So with my division again, I'm going to divide the first term of the divisor into the first term of the dividend. 4x to the third divided by x squared equals 4x. So that's the next term in my quotient, plus 4x. It's also what I'm going to multiply my dividend by. So 4x times x squared minus 3x plus 5 is 4x to the third minus 12x squared plus 20x. And that's my subtraction step, so I'm going to put that back into my equation. Complete my subtraction, cancel out those first terms. Negative 15x squared plus 12x squared is just negative 3x squared. 4x minus 20x is negative 16x. And then don't forget your b. You have to bring down that last term. So minus 6. And I'm going to continue with my last DMS cycle. So the first term of my divisor is 3x, negative 3x squared divided by x squared equals negative 3. So that's part of my quotient. And it's also going to be my multiplication term, negative 3 times x squared minus 3x plus 5 is equal to negative 3x squared plus 9x minus 15, which gets substituted in for my subtraction step. Negative 3x squared minus 9x minus 15. So my first terms cancel out. Negative 16 plus 9 is negative 5x. Whoops, I'm sorry, that should be a positive 9, so that makes it negative 25x. Negative 6 plus 15 is positive 9. And I have no more terms to bring down. So this bottom number that I have so far, negative 25x plus 9, that's my remainder. And what's above my quotient bar is my solution. 3x squared plus 4x minus 3. So if I want to go back and check my work, all I need to do is multiply the dividend times the quotient and then add my remainder. And I should get my divisor. So you can do that out on your own. You could double check it in a calculator. It's up to you, but that's the quick and easy way to find out if you have the correct solution. Example 2. Again, we're going to use a really similar process for just dividing polynomials. X minus 2 gets divided into x to the third plus 5x squared minus 7x plus 2. And notice that there's no exponents missing. I have 3, 2, 1, 0 for my constant, so I don't have to substitute in any 0 coefficients for this problem. Again, I'm focused on the first term in my divisor and the first term in my dividend. And I'm going to do my division. X to the third divided by x is equal to x squared. So that's going to go over my quotient bar, and it's going to be the term for my multiplication. X squared times x minus 2 is x to the third minus 2x squared. So that's my first DMS cycle there. I'm going to plug that in as my subtraction step. X to the third minus 2x squared. First term gets canceled out. 5x squared plus 2x squared is 7x squared. And bring down my 7x, negative 7x. And then continue with the first term for this cycle. 7x squared divided by x equals 7x. 7x is my multiplication term. It also goes up on top of my quotient bar. Times x minus 2. 7x squared minus 14x is my subtraction step. So I end up with 7x, bring down my next term, plus 2. And we're in our last DMS cycle. 7x divided by x equals 7. 7 times x minus 2 7x minus 14 gives me, whoops, positive 16 as a remainder. And my solution is x squared plus 7x plus 7. And again, you can go back and check that with your calculator by multiplying the divisor and the quotient and adding the remainder to get the dividend. Example 3a is a little different. We are going to be using what's called synthetic division to solve this problem. And synthetic division we can only use when our dividend is in this form of x plus or minus k. So I've got an x and I've got a constant. The formula itself is actually x minus k. So this is one of those situations that when we have, like in this example, x minus 2, the k that we're going to use is just a positive 2 because it's in that negative form already. If I had x plus 2, I would have to use a k of negative 2 to account for the formula being in the negative. So it's kind of like when we were going back and graphing those quadratics with the p's and the q's. When there's a negative in the formula, you have to make sure that you're accounting for it and you have the right integer for your problem. So let's set this up. This is a little different. What I'm going to do is take that k value and put it on the outside. So I have 2. And then I'm going to draw an upside down division sign. And then I'm going to substitute in the coefficients for my divisor. So x to the third has a coefficient of 1. Negative 2x squared has a coefficient of negative 2. 3x is 3. And negative 4 is negative 4. So I plug in all my coefficients, and then I'm going to follow this procedure. First thing I do is take that first coefficient and drop it down underneath the division sign. Then I'm going to multiply my k by that first coefficient. So in this case, that's a 2 times 1 equals 2. 2 times 1 equals 2. And I'm going to substitute that 2 inside the division bar underneath my second column. And then I'm going to add down that column. So negative 2 plus 2 is 0. And I'm going to repeat that process. So I'm going to take my k value, which is 2, multiply by 0, and put the solution inside the next column. 2 times 0 is 0. And then add down. 3 plus 0 is 3. Multiply again. 2 times 3 is 6. Add down. Negative 4 plus 6 is 2. And I'm done. So this is how we read our solutions. The last number is your remainder. And then moving forward is going to be your solution. So this is going to have an exponent of 1, an exponent of 2, and an exponent of 3. So when I write that out, that's 1 x to the third plus 0 x squared plus 3 x plus 2. Now that remainder 2 is going to be written as a fraction over my divisor, so x minus 2. And that's just because it cannot be divided evenly, so I want to make sure that I'm keeping that into account, that I haven't actually divided that yet. I'm just using it as a placeholder. The 0x squared isn't necessary to write in your solution. So if you wanted to simplify this as much as possible, you could say x to the third plus 3x plus 2 over x minus 2. And that's it. So it's definitely less steps than using traditional division, but again, you can only use synthetic division when your divisor is in this form of x minus k. So let's look at comparing a long division processes to synthetic division. First we're going to do the long division. So over the side here, x plus 3 divides into 2x to the third plus x squared minus 8x plus 5. And I'm only looking at those first terms. So I'm going to do this without all my side notes just so that I have room to do the synthetic division afterwards, but please write down all the steps that you need to in order to understand this problem. X goes into 2x to the third is divided in, and what I get is 2x squared. 2x squared is multiplied by x plus 3, so that's 2x cubed plus 6x squared, and then subtracted from my problem. So my first terms cancel, and I get x squared minus 6x squared is negative 5x squared. I bring down the next term, minus 8x, and I divide again. 5x squared divided by x is negative 5x times x plus 3 is negative 5x squared minus 15x. Do my subtraction. First term cancels out. 8x plus negative 8x plus 15x is going to be positive 7x. Bring down my last term, plus 5. Divide 7x by x is positive 7. Multiply 7 times x is 7x. 7 times 3 is plus 21. Do my subtraction. So I get negative 16 as my remainder. And my solution is 2x squared minus 5x plus 7. Now, if I'm going to do this using synthetic division, I'm just going to set up my problem. Since my divisor is x plus 3 and the formula is x minus k, it needs to be a negative 3 on the outside. And then I'm going to write in my coefficients across. So 2x to the third plus 1x squared minus 8x plus 5. I'm going to follow my procedure, bring down my first coefficient. Negative 3 times 2 is negative 6. Add that column. 1 plus negative 6 is negative 5. Negative 3 times negative 5 is positive 15. Add again. Negative 8 plus 15 is 7. Negative 3 times 7 is negative 21. 5 plus negative 21 is negative 16. Now, as you see, I already have the same remainder, which is great. And when I look at my problem, I'm going to fill in those coefficients as necessary. So 2x squared minus 5x plus 7, and then minus, it's a negative, my remainder, which is 16 over x plus 3. So we did, in fact, get the same solution. It may have taken us less time to do the synthetic division. It's really up to you which method you prefer, and also which method is more comfortable for you, you feel like is worthwhile. So I will ask you to use both methods on a test. I may ask you to use them with the same problem so that you can check and make sure you're getting the same answer for both of them, but we shall see. Lastly, I want you to do your daily homework quiz. Again, I'm only checking today to make sure that you have completed those problems on your own. I really need to see where you're making any mistakes, but also where your questions are. So please write down your questions, do those as best as you can so that you're able to move forward in class the next time we meet.